right, looking at target 2.4, we're going to look at the first half of target 2.4 today. So we're going to use properties of right triangles now to find the sine, cosine, and tangent ratios. Okay. So what are some things we know about right triangles, right? The right angles, Pythagorean theorem, right triangles, all these things are other things we know about right triangles. So if we look at example number 4, it says find the cosine of angle A. So again, here's angle A. Let's label our sides. We have our hypotenuse, our opposite side, and our adjacent side. Well, now I find the cosine of A, then cosine equals adjacent over hypotenuse. My adjacent side is 8. My hypotenuse is 10. Which reduces to 4 over 5, right? Easy enough. That's exactly what we did yesterday. Now we look at example 5, find the sine of angle A. Well, same thing. Here's angle A. I have my hypotenuse, the opposite side, and my adjacent side. Okay? So if I was to find the sine of angle A, that's the opposite over the hypotenuse. Well, if we look at our picture, we don't know what the opposite side is, right? So right now, all I know is this is something over 10. So I need to know what what this something is. Luckily, we have Pythagorean's theorem. So, your hypotenuse is always C, and then A and B, right? Again, that doesn't matter. This A and this A mean different things, so be careful with that. But we have A squared plus B squared equals C squared, right? So that's 8 squared plus B squared equals 10 squared. 8 squared is 64. 10 squared is 100. I'm going to subtract 64. B squared equals 36. So B equals 6. I now have that this equals 6 out of 10, which is 3/5. Okay. So the Pythagorean theorem is this extra step to find what that missing side is before we can do set up our trig ratio. Okay, let's look at another example just like this one. Here we are finding the tangents of angle A. So again, now here's my A. So my right angle is here, so 9 is my hypotenuse. My opposite side. And then my adjacent side. Okay. So again, tangent of A, tangent is O over A, right? Again, I don't know what my opposite side is, but I know my adjacent side is 6. So let's set up our Pythagorean theorem. We have a squared. Well, my a squared is 6 squared plus b squared, right? A, b, c equals 9 squared. 6 squared is 36. If I subtract, then we have b squared equals 45. I'm going to take the square root. This goes back to our simplifying square roots that we did. I know 9 goes in to 45. So b equal, it's not 9 times 3, sorry, 9 times 5. And the square root of 9 is 3, and then square root 5. So that equals 3 square root 5 over 6. Now I want to simplify this fraction. 3 over 6, right? That simplifies to square root 5 over 2, or you could also put the 1 here. That's fine, but you do not have to put that 1 out in front. Okay. We get 1 square root 5 over 2 is our tangent ratio there. Okay? All right, looking at some more examples, just 2 more. If we're given one of the ratios, we should be able to find the other ratio. The only thing different about this problem than the problems we just did is for these problems we have to draw our own picture. So if we're given the tangent of theta equals 5/12 sine of theta. I'm going to start by drawing a right triangle and putting theta somewhere. Theta is my angle. My hypotenuse the opposite side, and the adjacent side. Okay. Lovely picture. So we get told that tangent of theta equals 5 over 12. What do I know about tangent? I know that tangent is opposite over adjacent. Okay. So then if we look, our opposite side is 5. And our adjacent side is 12. Now this looks exactly like those problems. Now that we have this picture, right, if I'm finding the sine of theta, well, I have my opposite side and I don't know what my hypotenuse is. So, A, B, C. A squared plus B squared equals C squared. 12 squared plus 5 squared equals C squared. 12 squared is 144. 5 squared is 25. If I add these up, I get 169. If I take the square root, 169 is a perfect square. It's 13. So now filling this in, this is 5 over 13, and that does not reduce. So the tricky part is kind of knowing where to put those sides, right? That's the new part of this. So let's look at example 9. Now we're given that cosine of theta equals 3/5. I want to change this. Let's do cosine of theta equals, I just want to do another one that we can practice our simplifying, square roots. So let's do cosine of theta equals 10/17, 10/17. And let's find the tangent of theta instead. Sounds beautiful. Just changing the whole problem. All right. We're going to start by drawing our lovely triangle. All right, put your right angle somewhere and put theta somewhere. I usually end up putting them in the same corner always, but it doesn't really matter. You could throw theta up there if you wanted. So then we have our hypotenuse across from here, our opposite side over here, and our adjacent side here. But we're given that cosine of theta equals 10/17, right? We're given this. And cosine is adjacent over hypotenuse. So then that tells us our adjacent side is 10. And our hypotenuse is 17. Now if I want to find the tangent of theta, right, that is the opposite over the adjacent. Well, I don't know my opposite side, but I know my adjacent side is 10. So let's use our Pythagorean's theorem. A squared plus b squared equals c squared. So I have a, b, and c. So that's 10 squared plus b squared equals 17 squared. And that's 100 plus b squared equals 289 is what 17 squared is. Feel free to use a calculator, right? Subtracting 100 from both sides, b squared equals 189. And then saving us some time, you would start like dividing by your roots, right, to see what goes in. But then I know it's 9 times 21. 9 is your perfect square that divides into 189. And the square root of 9 is 3. And then 21, we cannot take the square root of. So this is my missing side. All right, we could put it in here. Nothing simplifies, can't reduce anything. That's our answer. All right, we'll practice a lot of these in class, but have a good rest of your day.